on this side. Whoa. All right, recording. All right, guys, thanks for the videos. Let's see. And that is really delayed. Yeah, I'm going to do this problem over here and this one down, okay? So all we're looking at today is a combination of everything we looked at this unit, because we've had some problems that have, square roots in it. We've had some problems that have decimals, that could be expressed as a fraction. Here we have a fraction to deal with. So it's pretty much, we're dealing with systems of equations, right? Systems of equations where we need to solve for x and y given two equations. So remember the system has this little bracket here. And what that is saying is that these two equations, what we're trying to find is the solution that works for both of them, okay? Now that might sound a little confusing or abstract to start, but I'm going to start by doing this, and I say I would have you do the same. It's in function notation right now just to show their different functions, but we're going to rewrite them in standard notation just with x and y. So go ahead and do that first, and then I'll break down what our next steps will be. All right, so go ahead and do that. I'll let this person in. Great. Okay. So it's not, and once I show you this, I think it'll start to click. This is where, in this case, we're going to use substitution. When you had systems of equations, you might remember back in Math 2, Math 1, we used elimination. You guys remember elimination, where you add together the two equations? Maybe not. Substitution is the more direct thing, direct method, and that's what we're going to use here. The main thing here is that when you have a system, you could treat this y as if it is the same as that y, right? And since this y is equal to x, or the square root of x, what we're going to do is rewrite this and use substitution. Since I know that y is equal to square root of x, what I'm going to do is take that square root of x, I'm going to put it in for this y down here, make a brand new equation where I only have x values. So watch what I'm going to do. That's here, that's at 4 minus 0.5x. Oh. Okay. And there's a couple ways to go about this. Let's see. Let me think for a sec. Actually, this is going to be kind of a messy one. Let me see if I can change it slightly. Nah, we'll try to do it. I took this example and now I'm seeing it has more to it. But that's fine. The main thing is solving using substitution. You just have to recognize that within a system, this y and this y, we can exchange them. We could substitute in. Since y is equal to the square root of x, we can put the square root of x in for y, and you can see that's what I've done right here. Now, remember when we had the square roots, the way that we would get rid of the square roots, which is going to be our next step, is to square both sides, okay? So let's go ahead and set up this next step here. We're going to have to do another little baby step. Squaring the square root makes x just left over, okay? Now over here, we want to think of this as 4 minus 0.5x times 4 minus 0.5x. So we're going to have to do a little bit of a FOIL. And it is kind of weird. I looked, and this problem actually works out to be whole numbers, so I think it's gonna magically work out for us. And that is welcomed. Okay. So, this brings in a few different things that we've studied. It brings in the square roots. It brings in, squaring a quantity, which means we'll have to use FOIL. So we end up with x is equal to, we're going to multiply the 4 into both of those values. And then we're going to multiply the negative 0.5x into both the values. So let's see, 4 times 4, 16. Okay, I just did that one. 4 times 0.5x. So if you have 50 cents, you multiply that by 4. So 4 times a negative 0.5x is going to be negative 2x. Oh, that worked out. I thought that was going to be a real pain. That wasn't that painful. All right, next, we're going to take the negative 0.5x. We're going to multiply it into the two terms in that second quantity, we're going to end up with kind of the same values here, except, or at least the first one will be the same values. Negative 0.5x times 4 is negative 2x. Okay, I just did that one. And this last one, you know, you have negative 0.5x times negative 0.5x. And, you know, this is no shame. If you want to go and grab a calculator, you go negative 0.5 times negative 0.5. And we get positive 0.25x squared. Ah. All right, so we've done all the distribution. We did all that. Now let's combine some terms. I'm going to show you a trick or two here. Let's see, minus 4x plus 0.25x squared. Now, I don't really like this. When I move this x over, I'm going to rework what the order here. So 0 is equal to 0.25x squared. 4x minus another x, negative 5x plus 16. All right. 64 and 20. 64 and 20. Yes, perfect. All right, here is where we're going to make life much easier. Because remember, or I'll let you guys finish getting that down. I think this one's as complicated as it'll get for your homework. You got 4 problems for this. All right. So for those that just came in, remember we can substitute with a system. That's what we're doing. We're substituting in this y for this y. Since y is equal to root x, I plugged it in here for this y, and then I just went about solving for x. That's all this is, solving for x, solving for x. We get down to this step, and this is where I'm going to show you a little trick. Because remember, you can multiply both sides of the equation by anything you want, and it doesn't change anything. It doesn't change anything. So remember, what's the hardest part about this trinomial over here? Because we're going to use the x method, but what's the hardest part? This part. We don't like that part, right? Because we can only figure out the x method when that's 1. So tell me, somebody in the chat or speak up. What are we going to multiply both sides of the equation by, which won't affect the left side because we're multiplying by 0. But what can we multiply both sides by to make this into a 1? Good, Dave. Anyone else? Nice. Dave's on it. Anybody else got it? What can we multiply both sides of the equation by? So all of this will be multiplied by something. The 0 will be multiplied by something. Just to get good, Hunter. Just to get this first term to be 1x squared. How many quarters in a dollar? Good, Brian. Take a guess. Not quite, not quite. All right, here we go. Watch. I'm going to multiply by 4. This is kind of like a little clever thing. I don't think you'll see a problem like this all the time, but I want to teach it to you because watch what's going to happen. 4 times 0, 0. Ah, that's nice. Didn't mess that up. 4 times 0.25. 4 quarters. 0.25 is a quarter. 4 times 0.25 is 1x squared. Ah. 4 times negative 5x is negative 20x. 4 times 16 is 64. Okay. Now we're going to do some of this. 64. What multiplies to give you 64 adds to give you negative 20. You might say that this problem has a lot to it. Yeah, that's why I give you 4 different problems for homework, because it kind of combines everything from the unit. Okay. I look here, I'm going to say, well, what gives me 64? What multiplies to give me 64 and maybe adds to give you negative 20? I don't know yet. 8, 8, negative 8, negative 8. 16. Whoa, excuse me. Oh, just to give us 64, yeah. 16 and 4, negative 16, negative 4, 32 and 2, negative 32, negative 2. Okay, and do any of those add to give me negative 20? Yes, sir. Yeah, this one. Okay, so this brought together a lot of things we did in this unit. We have negative 16, we have negative 4, and that's what I'm going to put up here. x minus 4, x minus 16. All right. And then we are going to 4 minus 4. Okay, 16. Why isn't 16? One sec, I gotta check something. That's fine. Okay, so when we solve and find this out, we're basically seeing when does this, what is my x value going to be? Because I'm looking to see when does this quantity equal 0? Because something times 0 will give us our 0 over here. This is where we had this, where we were just double checking. And we can write it out if you need to see when does that equal 0. It equals 0 when x is 4 and when x is 16. Okay. So what we're doing here is we're finding two solutions here. We just figured out, and this is going to be like our answer right here. It's going to have an x and a y. Okay. So we figured out that our two possible x values are 16 and 4. So what can we do? What can we do to find the y values? If you know the x value, what do you do to find the y value? You just plug in your x value, figure out the y value. Okay. So look what I'm going to do. I'm going to take 4. I'm going to look at my first equation way up here. Y is equal to the root of x. This is kind of like the second part right here. But I don't have to do much work because all I'm doing is plugging in my 4 for x up here. Let's see, when we plug in 4 for x, what do we get? 2. Then I'm going to plug in my 16. So what you're doing is you're plugging your x value into your original equation here that we took down, and it would work for both of them. But I chose this one because this equation's easier. The square root of 16 is 4. And those are going to be our two answers. Okay, because both those answers will work if we made them equal to each other again. Okay, so it's a lot to it because these problems combine a lot of things from this unit, but it is all a matter of first substituting in what you know for one of your values into the other place, and then carefully working out your x values, plugging in your x values to find your y values. That's it. It's just a lot to it. It's a lot to it. And we'll have time to look over these. Since it's 4 problems, we'll definitely be able to look over it in the next couple sessions here. Okay, now let's do the other one. Let's do it. First step, rewrite it in terms of y instead of as a function notation. You see? So first I just rewrite it. I get rid of, they denoted that this was the f function versus the g function. And instead I then just make it equal to y. And the key thing here is that, again, substitution, that y is equal to that y. And what does y equal in this top equation? Y equals 1 plus 1 over x. So what I'm going to do is I'm going to take this and I'm going to put in there for the other y. That's all substitution is. It doesn't matter what the equations look like, what the functions look like. You just have to basically isolate one of the variables and then plug in what it's equal to. So we end up with this. 1 plus 1 over x is equal to x plus 1. Okay. Now this was the last lesson we did. This was the one where we had equations that involved rational expressions. This is a rational, right? It's a ratio, a fraction. So when we have equations involving fractions, what we want to do is we want to find, this is where we want to find the LCD. LCD. And I'm going to make all of these fractions just so I can show that the LCD, the least common denominator, involves all of the denominators. Okay. So the LCD is looking at what is the least common denominator from all of the denominators. Okay. What denominator can we have here that all of those denominators can go into it? And it looks like we have 1, we have x, we have 1, we have 1. So tell me in the chat, what do you think our LCD is going to be in this case? What is the LCD in this case? What do you think? That's pretty straightforward. It's pretty straightforward. Good, Dave. Anyone else? Good, Brian. All right. Our LCD is going to be x. Why is it x? Because 1 goes into x, x goes into x, 1 goes into x, 1 goes into x. Right? 1 goes into x because it is 1x, right? All right. Good. All right. So now what we have to do is we're going to take this set of equations, and I'm just going to rewrite it as we had it before. And what we're going to do is multiply the LCD, multiply every single term by the LCD. So I'm multiplying by x. I'm multiplying by x. I'm multiplying by x and multiplying by x. Okay. All that, everything we just did was for this. We have x over x. That gets rid of, x over x is 1. So that gets rid of the denominator for the whole equation. Look what we're left with. X plus 1 is equal to x squared plus x. I'm looking at this. I want to get everything to one side, but when I move over the x, look what we end up with. 1 is equal to x squared. I'm just going to leave it like that. I'm going to solve it. Okay. So this lesson and these problems are looking over, reviewing a lot of what we did in the unit, but also giving us some practice solving equations, which is going to be good for the next unit. So what is the opposite of squaring something? The opposite of squaring? Square root. What? Square root. Square root. So remember, we had x squared. We square rooted both sides so that we could cross out the x squared. And let's see what we end up with. We got x is equal to the square root of 1. What times what gives you 1? Well, it's going to be plus or minus 1. Because negative 1 times negative 1 will also give you 1. So here is our x values. I'm going to rewrite, put the answers down here. Really messy today. Sorry about that. We have our two x options. Remember, the square root of 1, we asked the question with square root, what times what gives you positive 1? Negative 1 times negative 1 also gives you positive 1. That's why I had to put both of these options here. Okay. And then what you're going to do is you're going to take the easiest one to deal with. I think the first equation, this is step 2. The second equation is the easiest to find y. Right? We take our second equation. You could have taken the first one, but that makes it, it's a little bit harder. So look at your second equation here. It's going to be easy to find your y values now that we know x. So watch what we're going to get. We're going to end up with, using our second equation here, I'm going to plug in 1. 1 plus 1 equals 2. Right? I plugged in 1 for x. So it's 1 plus 1, and that equals 2. All right? So y equals 2. Y equals 2. Next, we'll go negative 1 in for x. Y is equal to negative 1 plus 1, and that equals 0. Done. Yep. So it's a lot of stuff you've seen before. This unit, it is a little bit tricky in some ways, but just know we're going to look over these homework problems on Thursday at the start of class. So maybe get through 1 or 2 of them, or maybe look over and be like, this one looks like the hardest one, and go after the hardest one first. All right, let me know how we're doing. Thumbs up, sideways, down. Can we work hard to get through it? Probably just have to work a little bit hard for it, Okay, good. Okay, mostly thumbs up. That's good. All right, well, as mentioned, I need to leave a little early today, so I will stop the video